Well, thank you for joining us on exercise 3G. I'm going to be looking at part C. This is find the complex number z that satisfies the following equation. And our equation is if I can get my pen to work, which is not working. Z plus 2i, 2 plus I equals Z minus 1, 1 minus I. Let's just have a closer look at that one. Is it a 1? Yeah, that's a 1. I made a mistake last question. I chose a 1. I thought I was a 1. I missed the dot. Okay, I think we're correct. Let's expand both sides. And so I will expand the first loop. Z times 2 is 2z. Z times I is zi. 2i times 2 is 4i. And 2i times I is 2i squared. That's the left side. Now the right side. So we've got z times 1 is z. Z times negative I is minus zi. Negative 1 times 1 is negative 1. That is a 1, yeah, okay. And finally, negative 1 times negative I is plus I. Good. Now let's look at the 2i squared, because I squared is negative 1. So 2i squared is 2 times negative 1, which is negative 2. So let's replace that. I'm going to put all the z's on the left. So I'm going to leave the 2z there on the left. I'm going to leave the zi there on the left. I'm going to bring this z across to be minus z here. I'm going to bring this across to be plus zi. I'm going to take this 4i across to be minus negative 4i. I'm going to take, that is a negative 2, right? Remember that? I'll take that across to be a positive 2. And we've still got a minus 1 and a plus I from above, still on the right-hand side. Good. Let's factorize the z on the left. We've got 2 plus I minus 1 plus I. And let's group these. 2 minus 1, the real components, is 1. And negative 4i plus I is negative 3i. Okay, that should be good. Let's work out this bracket over here. And we've got 2 minus 1 is 1, and 2i, and 1 minus 3i on the right. All we need to do now is take that bracket across that's multiplied by the z and put it on the other side as a divide. So on the numerator we've got 1 minus 3i. Now on the denominator we've got 1 plus 2i. And this is where we multiply by the conjugate of the denominator. If the denominator has a plus, our conjugate has a minus, so 1 minus 2i, 1 minus 2i. That will get rid of our imaginary component on the denominator. So what have we got? We've got 1 times 1 is 1. 1 times negative 2i is negative 2i. 3i times 1, negative 3i times 1 is negative 3i. And negative 3i times negative 2i is positive 6i squared. And our denominator, using the difference of 2 square rule, because when you multiply by a conjugate, you are using the difference of 2 squared rule, which is a squared minus b squared. So let's use the a squared minus b squared principle. So 1 squared is 1 minus 2i squared is 4i squared. 2i times 2i is 4i squared. Let's replace, because I squared equals -1, let's replace 6i squared with -6. And let's replace -4i squared, -4 times -1, with +4. 1, take 2i, take 3i, minus 6, and 1 plus 4. Okay, let's group here. We got 1 minus 6 is -5. -2i minus 3i is -5i. 1 plus 4 is 5. So we've got denominator is 5. So -5 over 5 is the real component. And -5 over 5 is the imaginary component, which becomes -1 minus 1i. And I hope this has helped. Until next time, stay happy.